Okay, so for this video, we're going to be talking about the solution to a linear and a quadratic system of equations. So basically, I want to know when the line and the quadratic or the U-shaped figure is going to meet. So understand that there can be one answer, there can be two answers, or there can actually also be no answers. Two is because a quadratic is x squared, so the most it's going to have is this 2 for the exponent. First, I want to show what it's like graphically. We're not going to do that, but you could just plug these in your calculator and see where they meet. So if you're just looking for the answer, you can put them in your calculator, but I'm going to be asking you guys to solve them algebraically, so you're going to have to do work. So here we go. This first one here, you can hopefully see that there are two solutions, or two times when they meet. This one here, only one, and these never touch. So the solutions here, what are they? It's the two spots. So we'd guess this one here, which is 0, -3, I would say, for that one. And the second one, we would probably say, looks like 4, 5. Okay. And then you'd want to guess the other ones. All right. So for this one here, it only touches once. And that looks like -2, 5. Well, we know it's definitely 5 because it says y equals 5. So -2, 5. And then this one is imaginary. They never touch. All right. But you could plug those in your calculator and it would tell you where. For today, our goal is to do, how do we do it mathematically? Instead of putting these in the calculator and trying to see where they meet, which we could do to check, I want to set them equal to each other, which means get rid of the y. Now, if one of them's not in y equals form, you could do substitution, but we'll talk about that another time. But for today, I want you to set them equal to each other. So I'm going to write, instead of y equals, I'm going to write just x squared. And then I'm going to write plus 5x. And then I'm going to write plus 6. And I'm going to set it equal to the other one, which is in y equals, and write x plus 6. So I'm basically getting rid of the y, set them equal to each other. We've done this in the past. Just as we did substitution, we did set them equal to each other. Now we're going to solve. All right. So what we want to do is get it equal to 0. So when we set them equal to each 0, we're now going to use the 0 product. So we're going to set them equal to 0. I'm going to move this x over as a minus x. I'm going to move this 6 over as a minus 6. We now have a 0. Put a line, x squared. 5 minus 1 is 4. And that goes away. That becomes 0. So in this case, I'm going to use whatever type of factoring I can. If I want to use the quadratic formula, I can also do that. But in this case, I'm going to factor. There's no 0 here, so I don't have to do two numbers that multiply to this or add to this. This is called GCF. So I'm going to pull out an x, and I'm left with x plus 4. Set them equal to 0. And remember that there's probably going to be two answers. So at this point, I'm just going to tee it off. Set them both equal to 0. The first one is 0. The second one is 0. Well, that's already 0. And the opposite of plus 4 is minus 4. So I am done finding out the two answers. But that's not the final answer. So if this was asking where does it cross the x-axis, we usually just solve for x. But these are spots where the 2 points meet, or the two graphs meet. So one of them is going to be 0, comma something. And the other one is going to be 4, comma something. I need to go find the somethings. What I usually do is take the x and plug it back into the easier of the two problems. I'm going to go back up here and put a 0 in and put a 4 in the easier of the two. Well, to me, the easier of the two is this one, because all I have to do is add 6. Hopefully that makes sense. So you got 0 and 4. I'm just going to plug in a plus 6. So what's 0 plus 6? Oh, that's 6. So that's going to go over here. And what's 4 plus 6? Well, that's 10. So that's going to go here. So my two answers are 0, 6, and 4, 10. Okay, try a couple more and show you that it could get a little more difficult. Now, when it says when does f of x equal g of x, again, that's like y equals, but when are they equal? Well, it doesn't say a solution, it just says equal. So you don't have to actually plug it back in, you just have to tell the x value. All right, so once again, we're going to set them equal to each other. So we'll write that. We're going to set them equal. Move this over as a minus 7x. Move this over instead of as a minus 16, a plus 16. Those are now gone. Set them equal to 0. It's called the zero product property. We're going to get 30. We're going to get negative 17. Okay. So at this point, I now need two numbers that multiply to 30. Sorry, that number goes down here. And it's going to add to be the top number, which is negative 17. Okay, now you could have used the quadratic formula for this if you wanted, and just done A, B, and C. That's up to you. All right, so I know numbers that multiply to 30 are 10 and 3, but that's not 17, 15 and 2. Boom, there's my numbers, but I need a negative and a negative. And there's my two answers. A negative times a negative is a positive. So what I'm going to go with is x squared minus 15x minus 2x plus 30 equals 0. And I'm going to factor that with GCF. I get x parentheses x minus 15 because they have an x in common. These have a negative 2 in common. Remember, if the third one's negative, pull that out. And then you just come over here and finish it up. So you get x minus 15 equals 0. And you also get x minus 2 equals 0. All right. This answer, the opposite of minus 15, is a positive 15, and the opposite of minus 2 is a positive 2. And there's your answers, 2 and 15. Now remember, if this was a problem that says solve it, you'd have to take the 2 and the 15 and plug them right back in here to get the y values. But in this case, when they say when does f of x equal g of x, you don't have to. All right, one last one where we have to do the whole thing. Find the point. All right, I'm going to do it a little bit different. So here we go. Set them equal to each other. X squared minus 6x minus 10 equals x plus 8. So I'm setting these equal to each other, getting rid of the letter y. Get rid of the x, minus x goes here. Get rid of the 8, minus 8 goes here. Draw a line, x squared minus 7x minus 18 equals 0. So at this point, I may be unsure of when or what numbers multiply to be 18 and combine to be 7, negative 18 and negative 7. So I'm going to use the quadratic formula. So I'm going to say x equals negative b. Well, b is negative 7, so it's negative negative 7 plus or minus the square root of b squared, that's b squared, minus 4 times a, which is 1, times c, which is negative 18, all over 2 times a, which is 1. Plug all this in my calculator. A negative negative 7 is a positive 7. And the biggest thing here is you could just plug all this in your calculator. Hopefully it comes out right. So negative 7 squared minus 4, 118. So I'm going to do negative 7 squared minus 4 times 1 times neg 18. Answer 121, which when I try it out, is it a perfect square 121? Yes, it is. It's numero 11. So therefore, we get plus or minus square root of 121 all over 2. Let's go down a little further. We get x equals 7 plus or minus 11 over 2. So what that really leaves me with is two answers. X would equal 7 plus 11 divided by 2. So 7 plus 11 divided by 2, that's 18. Divided by 2 is 9. 7 minus 11 is -4 divided by 2 is -2. And remember what I said. These have to be solutions, so therefore I have to plug back in. So I know my answer is going to be 9 comma something and -2 comma something. Time for me to go find the something part, the y's. So I'm going to go back in and pick the easier one to plug it back into and put a 9 and a -2 in. So I'm going to do this one here, which is plus 8. If you see that there, all I have to do is add 8. So y equals x plus 8. So y equals x plus 8 is what I'm going to do. I'm going to put a 9 in. 9 plus 8 is 17. And I have a -2 plus 8. And -2 plus 8 is 6. So I'm going to use 17 and 6. And that's my answer, 17 and 6. And that's how you do systems of linear inequalities. Again, you don't have to use the quadratic formula. You could factor, but you got to do something algebraically. At this point, I've showed you factor, quadratic formula. Make sure you set them equal to each other. And if you're not sure, you can always check yourself by going in your y equals, plugging both equations in, and then hitting graph to see where they meet. Okay? See everybody for Google Meet, and try to get these done as soon as possible. Take care.